Hi, John.
Hi,
Good.
sir.
How are you?
I'm good, sir.
Okay. Yep, it's nice to know. So, yeah, for today's session, yeah, I'm not sure if I can cover the 2 hours for the lecture because I'm suffering from a red eye on my on my right eye. So, originally, I thought that I can do the classes today, but yeah, I think uh, we should cover like until window functions, and then after that, we can assign the stuffs to them for practice. Because no, next week would be the last week for um SQL, and yeah, I have to jump into Microsoft SQL Management Studio and show how, like, from an Excel file, how can they do SQL queries and how can they create their own tables, delete rows and columns, all those stuffs. So let's see if how can we squeeze everything next week. Okay. Also, during the session this week, I think Nia and Anissa did not join, so
Yes, sir.
it'd be great if you can um catch up with them, try to know what's happening. Okay.
Okay, sir. So last time I messaged Anissa,
Hmm.
and the last message that she sent me was on May 11. She
Okay.
said that she feel unwell,
Okay.
but she
Yeah.
will try to participate. But that's last week.
Last week. Okay.
Yes, I'm not sure what's the latest
Okay.
update, but maybe I will try to reach her out
Yeah.
again.
Just try reaching out to her and see the update. Okay. Hi, Asiba. Welcome to the meeting.
Hello.
Hello,
Yep. How are you?
I'm good. How about you,
Okay.
Andrew?
Yeah. Um. Yeah. Let's wait for the others, and yeah, maybe with one or two additional
Sure,
students, we can start. Yep.
sure. John, I have difficulty with lab 10. I would definitely need your help today after the lecture.
Okay, I think that's about the different kinds of joints. So
Oh.
the four questions about the joints.
Yeah, we already discussed that the last time. Like, I already gave them the conceptual thing, like the differences between this inner join, this left and right outer joins, and also the full outer joins. So basically, for the meeting today, the focus would be union and window functions. Yeah, I think the discussion would for the union would be um, very quick because the concept of union and union all is very simple. I should say more like more simple as compared to the joins. Okay, I'll be on standby for a couple of minutes, John and Hasiba. I'll be back, okay? While waiting for the others. Okay, I think we can't wait for any longer. I think Hasiba will be the only one during the session. Well, it's weekend. Um, Life happens, so the others could be attending to something important. So, Hasiba, is it okay for you to
Yeah,
uh,
I'm here.
start? Okay, okay, perfect.
Sir,
So,
Jeff will be late for 30 minutes.
oh, I see,
Message.
I see.
Message me.
Yeah. So, yep, let's start the session and let's do a quick recapitulation of what we discussed the last time, just to refresh things up. Okay, can you see my screen? Okay, there we go. So, so the last time we talked about this different types of joins. We talked about um, the inner join, which is basically a more a smaller table because the resulting table would only have those columns and also records that are common between the two tables that you've joined. So it's all about those um, common records in your common field. Okay, the one that you point on the on the on clause, right? So the on identifies, okay, what are the rows that would be um, well, actually the on in the end identifies, okay, what are the like um the basis for joining the two tables. So in our example, you've seen that I think um, the questions in the lab would make use of that table about I can't remember it exactly, the teams and the players tables, right? So in that, I think you'll be using I forgot the name of the specific column, but with the companies and investment tables, you can use the permalink, just like a directory of the companies and the specific acquisitions. And we also have here another type of join, which is the left join. So this is a much larger table because, well, even though there are no matches between those records in this first table, the left table with the records on another table, it would still be included in the resulting table. Okay, but there would be tons of missing values, right? So for those columns that will be coming from table two, those would have missing inputs for the result or in the resulting table. And we have the right join, which is basically uh, um, the left join, but instead of retaining all those that are from the left, you'll be retaining all those that are from the right, even though there are no matches from the records on the left table. So these are just like the same thing. So switching the position of what you put in the from clause and in the um, uh, rather on the join, right? The join and the from clause actually identifies um, whether you for example you want to do a left or a right join using the left join. So you would observe that um, the right join is being used less frequently because again you can still accomplish the same thing by just switching the table using the left join. And when we have the full outer join, so basically this is a very big table that has so many missing values because with all the records from the left table and all the records that um, are on the right table, even without any matches, those would still be included together with those that have matches from both the tables. So this would be a very large table, however, um, a not so pretty one because of the existence of so many missing values. Okay, and then um, we talked about the advantages of using multiple keys in doing SQL joins. So first, it improves the accuracy, right? So the more uh, common fields that you use for or ask multiple keys, the more accurate, okay, the resulting table would be, especially if both the tables are of size. And then we have the performance. So this performance is uh, well specifically relating to speed. So you would observe this if you are joining uh, a very large table. You would see that okay, um, it runs relatively faster as compared to just using only one um, key. Okay, but of course, if um, you'll just be working on a relatively small data set, then it will not be too evident. So the difference would be very negligible, so that it appear that it's almost the same. Okay, so this benefit number two would um, only be evident for very large data sets. And we had this example that yeah, the one at the top is basically the same thing as one at the bottom, but uh, with the one at the top, we are using two keys to join the two tables, this companies table and the investments table. Okay, and one thing as you can probably observe here is that we're not using the as, so the system automatically knows that we're trying to provide this aliases, okay, to these two tables. Okay, and we can also do that in the select clause even without the as. Okay, but again, um, in order for our codes to be more readable, I still suggest you to use the as. Okay, but it's just another knowledge that it's not really required. Okay, so we have here the soft join. So a soft join is like joining a table in itself to take advantage um, the relationship between the columns and the rows of that table. So in this example, as you can see, we have this manager ID that is related to the rows, okay, of the ID column. So basically, this identifies who is the manager of who. So, for example, John Smith, his manager is number three. Okay, so if you look at ID three here, so it means that John Smith's manager is actually Tom Lennon. Okay, and so on. So if you want to take advantage um, of that relationship between the columns and the rows, you can use self join. So self join is not really that intuitive because yeah, in the first place, well, you can avoid using self join if you plan it carefully. So instead of just referring to numbers here for manager ID column, you can specifically state the actual names. But oftentimes people do this to make it more faster to encode things, like instead of writing the entire name Tom Lennon, they will just be putting number. So then in the future they can just extract that. Oh, okay, this manager ID three is actually referring to this person and so on. So they try to be efficient and they try to minimize that requirement for storage. So that's what's happening here. And we had this example about, okay, how can we identify the actual name of this of the managers of this particular person? So basically through this, so we apply this different aliases. okay, to the same table, and we just took advantage of the fact that okay, these numbers that you're seeing in this manager ID column is just referring to this this value in the ID column, and particularly the name that is associated to that. So as you can see in here, Tom Lennon is managing John Smith and Jane Anderson, and Tom Lennon is being managed by Ann Connor. And it seems that Ann Connor is actually the boss here, because if you go back into the um to the earlier table, you can see any manager ID associated with Ann Connor. It seems that at the hierarchy of position, she is the top, right? He's on the top, so probably the boss. And in terms of salary, she has the highest at 2,000. So it's, I think, realistic to assume that. Okay, and we actually burn like we burn significant amount of time here because this is not a simple practice. Um, so this is pretty dense, and we were able to come up with this. The thing here is we want to identify those companies that received investment from Great Britain after being invested by a company from Japan. So we have to take advantage of the fact that okay, this table, okay, this investment table contains those company names and company code, or yeah, company country code rather, right? This country code or investor rather, sorry, i- investor country code that identify okay, this company is coming from Great Britain or Japan or other companies. Okay, so basically here, as you can see, this part right here is acting as a filter, right? So this self join and the use of multiple keys on self join can actually function as a sort of filter. So basically here, what we're saying that okay, we only want those that are with country code Great Britain, and this line right here specifically states that okay, it should be um, funded early in the Japanese investments, right? So this line right here, the second end, specifically states that okay, it should be much recent. Okay, this GBR investment must be more recent as compared to the Japanese investment. Okay, so here we are just applying the this thing to see this actual company names. So there are other practices that will be assigned to you later to practice this. So you can do it together with John. So so the focus of today's lecture would be union, union all, and lastly, window functions. Okay, most probably you've encountered in the past the SQL queries that has this computation. Okay, this computation of descriptive measures in the select clause. We'll be utilizing that to answer analytics questions. So let's start with union. So what is the union operator? So union allows to stack one data set on top of each other. So what we're actually doing with joins, okay, is to stack the the tables, the data set side by side, right? So if you have this different fields or characteristics or columns of the other table, it would be stacked together with the other table. So that's what's happening with joins. Okay. But with union, we're stacking data set on top of each other. So basically, this means that both of the tables must have the same number of columns, and those columns must be of similar data type. Okay, so you might be thinking, okay, Jeff, so basically you're saying that table one must contain like the same characteristic, the same um variables as with the other table? Yes. So when is this useful? So imagine if you have like if you're trying to merge this multiple tables together because they have different dates, right? But they refer to the same like the same variables. You can do that. Union is the way to go. So in order to visualize that, um, maybe we can switch back to Microsoft Excel so that I can give you like an example for this one. Yeah, apologies, my alarm is very noisy. Okay, so um, in order to visualize what's going on when we do a union, let's imagine having three columns, column B and column C. Okay, these three columns must have the same characteristic as with the other table. Okay, so I'll be creating another table having the same number of columns that I'll be renaming this as maybe column A prime, column B prime, and column C prime. Okay, and maybe in order to further be realistic, let's identify characteristics here. This could be name. This could be age. Let me think. Uh, Maybe this could be sales. So this would be Jeff. This would be John, Hasiba, and Grace. Okay, and I'll just assign different age. I'll just guess. Okay, don't be angry. 23, 29. Grace, 27. Okay, and then we have the following sales. Say 300,000, or just 30K. 25K, 20K, 28K. Okay, um so for the other table, it should have the exact fields. Okay, but for example, let's see, if you have here a name, give me a name, John. Uh,
Gwel,
okay, Gual. Okay, teacher Gual. Okay, and oh,
Kubra,
Kubra. Okay,
Mustafa,
Mustafa. Okay, the previous students. And Leslie. Let me think. Okay, let's have John again here. Okay. So imagine John appeared twice in here, and then yeah, I'm just guessing about the age. And we have the following sales: 11K for Gual, 8K for Kubra, 9,000 for Mustafa, and then the different sales for John. Okay, if we stack it all together, okay, so basically it will just be a new bigger table, okay, with more rows. So you'll have the same number of columns here. So this would be table A or table 1. This is table 2. And then the merged table, okay, after applying union would be, okay, we still have those columns. Again, that's a major requirement for union. They should have the same number of columns and the exact data types. Okay. You cannot violate that. You cannot violate that. So it could be since there are no replications, only John, but John is not really a replicate because this record from the other table with John has a different record here. So what it does is here plus this one. So it will be stacked all together to form this one big table. So that's what you do when you do union, okay? When you do union. So, okay, you might be thinking, what happens if we have replicates? So let's go back to the slide and let's discuss things. Okay, so there are two rules. Both tables must have the same number of columns. The columns that must have the same data types in the same order as the first table. So you cannot jumble this. You cannot I mean, in the second table, you have the name first and then followed by the sales and the age. It should be at exactly the same order, similar to how you stack data in Excel, right? If you have like, if you're trying to pull this other data from another sheet that has like same columns, then it must be in order, right? If you want to extend it uh, by copy and pasting. So So we have here an example, and here's a comparison. Union only appends distinct values. If there are any rows in the second table that are exactly identical to the rows in the first table, then the rows in the second table will be dropped. So what do we mean by that? So imagine that we have another input here, such as this. So imagine that Grace appeared twice in the table. So there would be no replicate. So only one Grace would appear because the record is completely the same. Okay? Remember that. That's for the union only. However, with the union all, okay, but I think this another um word, or I should say code, with the union, it would append all values, including the duplicate row. So this is for the union. And when we do union all, what would happen is if you have this, you will have this column since the Grace would appear twice in this table, right? You would see Grace twice. So it would not drop any duplicate values, and that's mm, not so good, right? So, well, unless they are of the same values, they are identical because it just happened that they are identical, but they are referring to different points in time. Um, that could be one reason why you want to include both of the records, but most of the time you don't want any replicates in your data set because it would just skew the computed values for your descriptive measures, right? If you want to summarize for example, here the sales using a statistical measure such as average, then another record for Grace would really affect the computation in even as simple as getting the total, right? If you get the total sales for all of these people, having those duplicates would really affect it. Again, it depends on the thing. If it's a legitimate record done in a different point in time, then the differentiator would be actually that column for date. Okay, so there should be like this another column here that would specifically identify the date. So it won't be tagged as a duplicate. Okay, am I making any sense? Hasiba, Grace, Jeff,
Yeah, makes
Ashley.
sense.
Yep. So under the hood, this is what happened. What's happening when you apply those codes. Okay, and let's see. I think I've added here a practice. So let's see the part one and part two of this tutorial Crunchbase investments data. I'll just open my mode. Okay. Again, class. My intention for this meeting is to just finish window functions. I'm suffering from a red eye. Remember that last week I had this medication for my asthma, and I think it's quite related to that. My right eye has been pretty bad since yesterday. It's just red. I wish I can show you it, but I don't think it's necessary. It's not good. I think it's a um, side effect of the medication. I'm not sure, but it's painful. It's like having something on that eye. It got very dry. Let me see. Let's go back here in mode and let's visualize these two tables that we have in our deck. John, we have all of this deck in Canvas, right? Not chat, not open yet.
I'll check it, sir.
Yeah, so they should have a copy of this. Okay, because by the way, guys, this coming Saturday will be your final exam for SQL. We need to squeeze things up because I haven't introduced to you Microsoft SQL Server Management Studio. So I'm thinking maybe on Monday before we start with the discussion of subqueries, um, I should introduce to you that thing because you can practice with any data set using that, and it's also nice to create your own database locally in your computer so that yeah, you can use it for yourself or maybe you want to store um, important data. So anyway, yeah, going back here. So union, okay. So from tutorial dot Crunchbase investments part one, and I also want to see the part two. Wait, so this is more like an exploration since we're not familiar with this part two of the investments. So if it's like part one and part two, maybe just about the the dates for each of the rows, but should be referring to the same fields, company permalink, company names, and so on. So I think that's the case here. Part two is just an extension. Yeah, seems that that's the case. So we can apply the union, right? We can apply the union for this one. Oh, sorry. What did I do? Oh no. That is correct. I just need to remove that other other semicolon because the system identifies okay it should be the line and it should be a separate query, but it seems that I was trying to unite both of these tables together. So there are 100 rows right here. Let me see. Try to remove that limit at the top. Yeah, it's over the limit. Let me think. I can wrap. I can actually wrap this up with subquery so that I can apply the count function to have like an idea on the number of rows. Um, Hmm. Let me see. There should be a better way. There should be a better way here. Is there a wrong counter? 41,410. Yeah, 42,000. I think. This ID. Yeah. What I can do with this is I can just first look into the IDs, join all of those together, and then order by descending ID. Let me see. That would work. That idea makes sense. Yeah, there we go. Oh no no, 42483. Let's see. 42483. 42483 for the one at the top. 41410. 41410. So what I'm trying to accomplish here is to see the size of the resulting table. Well, unfortunately, we are limited with what mode allows us to have um with the free version, and I'm looking for ways in how we can see that. So 42483 is the size of the other table. Let me think. If we do this, if we do ID, guys, we are just joining by the IDs, right? Just joining by the IDs in here. So since the IDs are not unique, so it will only extend and up to the value in whichever is higher in terms of the count from both of this table. That's why it got the value of this bigger table at the top, right? Let me see.
Can you say that part again, please?
Sorry, this ID, if we specifically state it in the select, that that's the only record that would be appended here. Okay, so it would not include the other tables, the other columns in both of the tables. Does that make sense?
If we limit by 100, we wouldn't get any result.
Yeah, we would still get the result, but specific specifically what I want to show is, okay, if we join both of this table and we use everything like all of the columns, like we're stacking it together, right? I want to know the size, the number of rows, and I want to highlight that when I do this, what this expression is doing is just it's stacking all the ID records together. It doesn't include the other columns. So what you put in the select actually matters. Do you follow? So if you put here, for example, star, and you only put ID in here, let's see. it would result to an error because its union query must have the same number of columns. Does it make sense now? So what I'm trying to say here
Well,
is
basically, does it? So the idea is that you want to select the same column from both sides, right?
exactly,
But
exactly.
then, what about if the table has a little bit of difference? What's going to happen?
Difference in terms of what? Like the
Like
columns?
maybe, for example, if part one and a part two are very similar, except maybe part two has one extra column.
No, it will not be possible.
So you want to. So if you do a union, you will have error, right?
Yes, it would
They will
tell you
have.
this.
They need to have exactly the same number
Exactly
of
the same thing.
columns, like
Yeah.
the same exact columns.
Yeah. Exactly,
If
Jeff.
the columns don't exactly line up, like in our
It won't
example
also
with the
work.
3 column, it won't
It won't
work. It
it won't
ID
work.
has to
Yeah.
be first column in both of those.
Yes. Yeah. So
Okay.
for
All right.
example, yeah, if I have ID in here and say another table such as company code or permalink, and I have company permalink on the other, and then ID, this won't work. You remember we're stacking up the two tables or these two columns together. So there would be this um discrepancy because the first column is actually ID on the other table and then company on the other one, company permanent. So it's not possible. So it would only be possible if you have the same sequence, right? So this would work. This would work because it knows that okay, company permalink for the first column and then followed by uh ID. Okay. Do you follow, guys? Does that make sense? I think it's very important to highlight that. Okay. Let me see. Let me think about how can I do that. I want to bypass that limitation with mode, and try to. Yeah, we have 42483. We're actually able to do it here. So it seems that the size is 42483 for this one. Okay. Yeah, let's try union all. Basically with union, it omits, right, the common records. But so let's try doing union all and let's see the difference. Four two four eight three. It gives the same thing. Hmm. Let me think. I have this. I have this thinking that the only difference between these two is those extended rows in the part two. Let's see. 421 410. Let me see. Yeah, Bing networks. Oh, it's a different one. It's different. Hmm. I think missing something here. 2, 4, 8, 3. Hmm. Yeah. There are replicates on the eye. Ah, okay. That makes sense. That makes perfect sense. Yeah, because the ID would be the same for both of this. So this is ID one because ID is just a row counter for both of the table. So that's why it would only show me 42483. Um, yeah, because the other table, this part two table is just 414 for 410 if I can remember it correctly. Yeah, yeah. So the ID counter is not really a good count for the rows. Let me think of another way. Let me see. Hmm. I can definitely remember some other ways aside from like using the row counter in the table. Hmm. What if instead we use a count, right? A count of the company permanent or a count of the ID. Let's see. Goodbye. Let's see. Wonder if this would work here. Like count ID from must have an alias. Let's see. As tab, tab. Yeah, sorry. I'm just trying this thing, guys. I don't want to be unorganized. Tab doesn't exist. Hmm. Yeah, there we go. Perfect. So what I did here, guys, is an example of subquery that we'll be discussing on Monday or Wednesday. So basically, what I did is I treated this as one whole table. So since this is a working thing, I just use that information to have like a count of how many counts are there. And I'm assuming since we use union all, not all of this are actually distinct. So when we apply distinct here, we should expect that this would be way smaller, right? That we go for 2483. So you just give us the thing that we saw earlier. Okay. So it went back to the count for when we do union because it eliminates those those duplicates. Does it make sense, guys? I'm slowly trying to. Oh, I'm slowly feeling the dryness of my right eye. Okay, guys. And any questions with this? Um any question with the union all and with the union? Yeah, I think this discussion, this representation using Excel is
Still, sorry, Jeff, still a little bit lost on the whole part about when you select and you select from another
this
select.
one. No. Disregard it from now. For now, Jeff. What I did here is something that I haven't introduced to you, which is called an idea of subquery. What I want to just highlight here is the row count. That when we use union all, it would just give you even with replicates here. So it would be like the number of row from the other table plus the number of row with the other table. But when you do union, right, it would just be giving you the distinct, which is basically the bigger table. So that's just one thing that I want to highlight here. So please
Okay,
for now, yeah, please for now disregard this thing that I did.
got
Um,
it.
yeah, I just wrapped it up, but no. Let's be structured and yeah. Um, we'll discuss that. Don't worry, we'll discuss that. So yep, let's go back here in this discussion. So we just explored these two tables, try to show the theory that we have discussed that yeah the tables must have the same number of columns. The order, the sequence of those columns must be the same because yeah you're just actually stacking them together. So you're not specifying the order. There's no query with union and union all that would allow you to somehow jumble the column. So it should be like in a specific order. So like that's one nuance of it as compared with the joins in which the join would like even though the columns are not like sorted in the same way using the keys it would be able to look for those records. Well, John is doing that row by row, right? So if there's a matching record from the first table with the other table, it will get that stack side by side the columns associated to it. If there are no records for the other table, those would be filled with nulls. So that's what you do with it. But it's not the same as the same with union. Okay. So yep. So one distinction again, just like what we saw with the count. So it would include the duplicate rows for the union all. With the union, it only appends distinct values. Okay. So here's a practice that I want you to do with John later because I want to maximize the time. Um, John would be guiding you with the union practice. John, can you screenshot this and paste it in the chat box? I feel that I'm losing time. My eye is really getting really bad, and I would like to apologize. I'm getting very sickly. Um, yeah. Oops, I think I spelled the answer there. So let's proceed to window function. So basically, we have already discussed the concepts of union, all, and union. You just have to like apply it in practice through um, or in lab. So you can see it in action, like using this practice tables that we have in mode. So now let's proceed to this second part of the discussion. For now, guys, I will not be giving you a break. So maybe before you transition to lab, you can do that. So let's maximize the time. So we have this window function. So basically, window functions apply aggregate and ranking functions over a particular window or set of row. Okay, set of rows, which is very useful, right? Can you imagine the things that you can do with window functions? You will be applying only like for specific sets of rows the aggregate functions such as sum, the average, and the likes. Okay, maybe at this point you're not seeing the use of it, but let's see as we proceed along. So unlike regular aggregate functions, window functions don't cause rows to become grouped together into a single output row. Okay, rows return their separate identity, which is nice. Like for example, you want to get the summaries for like the first 10 rows, you can do that, okay, with window functions. And that's not possible with regular aggregate functions. So let's see. Okay, so this is the window function syntax. So we are selecting here, okay, and apply this aggregate function. So the aggregate functions, you already know them, okay. And this column name, so it could be like any field, any characteristic in your tables in your table that you want to get the aggregate function with. And over, okay, so this identifies like um the segments in which you'll be applying those that aggregate function. So the from clause is just self-explanatory at this point. So inside of that over, okay, you can optionally add one or both of the following: partition by. Okay, so narrows down the window for from the entire data set to individual groups within the data set. So as the name implies, partition by. Okay, this column would be partitioned by this. Okay, and then order by. So order by orders rows within the partitions. Or if there's no partition by specified, then orders the rows overall. Okay, so the thing inside this is not really required. So let's see. So this is the normal aggregate function, and what it does is when you apply the sum function, it just does the computation for all of the rows in this column duration seconds. It will just get the total. Okay. Now here, the difference with window function is this. Okay. So byte number, okay, those are just like additional characteristics, start time, end time. And here you have sum of duration seconds over blank as total duration all. So as you can see in here, byte number W01412 with this particular start time and end time, the total duration for all is equivalent to 344753515. To me, this particular value is not very useful at all, right? Without anything that we put in the over, you see that they're almost, well, exactly, not almost, exactly the same. Okay? So here, let's create a running total for the duration seconds column. So here we will be partitioning it by time. Again, here, the reason why the duration, total duration O is just the same for everything is that we don't specify anything inside the over. Okay, we did not partition it by, so the computation would be just the same for each of this rows. Okay, it would just put it like the total value for each of these rows, this thing. Okay, that's something that you need to remember. If you don't put anything in the over, the computation would not be done by a certain number of rows or by a certain condition, I should say. So it will just propagate, it will just populate all of these rows by the value that you will get from normal aggregation, which is not very useful, okay? Not very useful. So let's see an example in which we will be applying the order by in the over clause. Okay, so we'll be ordering it by start time. So there will be a running total here. So let's see. So John, can you do a screenshot of this and then let's proceed to mode. So the running total would be okay. For the first row, this is the duration plus the duration of the second row plus the duration of the next row and so on. So that would be a running total for us. Okay, so it's like cumulative sum, right? Cumulative sum.
So essentially with this way, the last row bottom in the bottom will be the the
The
ones that
total.
actually has that true total number.
Yeah,
Right.
yeah. So let's see.
Interesting.
Okay, so let's do from tutorial.dc bike share Q1 2012. What we want here would be the sum. It's a bit my is now doing very good. Duration seconds. We want to see that. Start time also. And what's the thing? Sum of duration seconds. And it is over start time, ordered by start time. By put it on the second line. Start time. And let's rename it as running total. Let's see here. Okay. So we see here the duration, right? The first duration was 475 seconds. And then that first value would then be added. Wait, let me see. Yeah, since these are same, there is there is a tie. So what it does is, since we're aggregating it, ordering it by start time, it would add those values that are associated with the same start time. So that would be 162 plus 1145, 2307 plus 475, which is 2782. That's what you typically do with ranks, right? If you think about it, we are applying the aggregate function, the adding by start time. So if you have the same, so what it does is, okay, you have the same thing here, 475 plus the sum of this. Does it make sense, guys, on how we
Uh,
came?
I feel like this is adding 475 to that start time, right? Or
Not really to the start time, but actually
but
to,
why are they both the same?
yeah,
2782
because the start time is the
when the
same.
durations are different.
Yeah, because you're ordering it by start time, not the duration. So this thing, Jeff, is considered as just one thing. So you have these two values, so they would be added together. So that would be 1162 plus 1145 plus 475. And since they are just considered as one thing, right? Because they are the same, they would both have that total 2782. So it's not really the usual running total that we do, that 475 plus 1162 plus 1145 and so on. So let's see if we do it. But
I'm
my
a little bit
explanation,
confused on that. I mean, but then
yeah,
adding, so they're both.
maybe this would help, Jeff.
Oh, okay. I think I understand because both of these are starting at the
At the
same
same time,
time,
yeah,
so
exactly.
that it would not actually have one that's. It would just go straight to the
Y-
total of
Yes,
both them
yes.
together.
It is just considered as one
So if
item, as
if the
one
start time is a little
position.
bit different, then it would the first 2782 would be like
Exactly, different.
maybe 116
Yeah,
something. Right?
exactly, exactly. So if this is different, like suppose this is 9, guys. Suppose this is 9. If that's the case, then 475 would be added here, because again, the system would recognize it as like a different start time. But since they are recognized as just the same, right? We order it that way, then as you can see, it considered it as just a single stuff, and both of the total here would be added here in the running total. So what would happen if we use the duration seconds instead? Would we observe like a different thing? So assuming the duration seconds is well unique, right? We would see a proper running total if that's the case. Let's see. Yeah, so this is just zero duration. These are supposedly missing values, so never mind. And then you have 126 right here. Oh, okay, okay. Now doesn't make sense. Yeah, I overlooked this one. So there's the possibility that the start time is actually, or rather the duration would be the same. This is actually worse, right? So, were you able to follow why this is worse? Because the duration could indeed be very much the same. The start time is much better. Do we have an ID here? Like a row counter. Usually we have. Let's see. Let's order it by ID. And assuming that ID is a row counter. Yeah, I think we don't have that here. Oh, oh no. Where is it coming from? Do we have that counter here? Yeah, we do have. So instead of just missed the comma right there. Order by ID. Hmm. What's wrong? Syntax error at your own. I don't need order. Running total. Sum of duration seconds. See. At or near order. Hmm.
So you put ID between the sum and the over. I
Yeah,
think
let me
that's the
see.
reason why it's
The order, right?
yes.
Of the column, I think so.
And there's
Uh,
a comma after the sum.
there's a comma after the sum. Ah, yeah, 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 yeah. It should be here instead because the sum is actually this is actually a one statement, right? Thank you very much, John. Let's see. Okay, limit limit reached. Yeah, this one is a proper running total, right? So Jeff, here it is in the group. So there's a well,
Oh, okay, I see it now.
yeah, there's a row counter here, so we can use that to somehow get a proper running total. Let me just.
So now because it's ordered by ID, not by the
Mm,
start time, that's why
ex-
it's actually adding for every one of them
yes,
rather than
this
like
yeah, this is a proper running total now. So it sees this IDs as different for each of the rows. So when he sees this, when the system sees this, the 475 would be added to the corresponding value here. Well, initially it would just get like 475 plus 0, 475. 475 plus the one associated with 2, which is 1162, 1637. This is unique, so it will be added to here and so on, right? So yeah, this is now a proper running total that we want. Questions, guys? Do you have any questions? My eye is very painful. Okay. So let's see. Let's see other example. So yeah, well, I think I overlooked this one. The start time. Must have you used the ID instead of that. Okay. Let's see. To create a running total of the duration seconds grouped in order by start terminal. So you'll just use the partition by here because you have basically um let me see. Start terminal. What was it? Start terminal. I want to see the start terminal variable. Try to predict what would happen if we use it in the over. Oh no, this is not a partition by. It's just the same thing as the earlier. Oh, what do you mean by start terminal? Start terminal. Could this be um like an ID of the terminal? Could be, right? Because what you do with partition by is you assign typically categorical variables in there. Let's see. Let's order it. Let's order by start terminal. If my thinking is correct, then this is a nominal variable. It refers to just it's like an ID. Yeah, there we go. That makes perfect sense. So these are treated as nominal variables. So you can think of it as like addresses or IDs of students. So yeah, we can use it in a partition by. Yeah, so here we are partitioning by the start terminal. So all of the start terminals that are the same, you would be applying the sum with it, and you're ordering it by start time. So let's see. Let's John, can you do a screenshot and let's do it together? Place it in the chat box and let's do it together in mode. Okay. So this is from the same table, right? Like share. Yeah. Can just copy this. Then what we want here is the start terminal. Right. Start terminal is 1. Then duration seconds. And then sum of duration seconds over partition by partition by start terminal order by start time order by start time. So the order by just identifies the sequence in how um the aggregate function would be applied to, and you can think of the partition by as something like a group by. So there would be this running total for each of the start terminal, okay, for each of the start terminal numbers, okay. And we have another condition here that we want to limit our results, where the start time is less than 2012 0108. Okay, let's see this one. And let me explain the thing. Duration seconds does not exist. Perhaps you meant to reference the column DC bike share. Where's that column? Start terminal. From this line. Um, okay. It's a missing eye. Look at that. It's a missing eye. That's the source of the error. Could identify where that thing is located. It tells me that okay, the rate in seconds does not exist. So basically here, guys, all of those start terminal with 3100, you'll be applying a rounding total to it. You'll be doing the summing up. And then once it encounters another set of terminal, let's try not to limit it by 100. I want to see the um, other terminals as well. Yeah, there we go. Perfect. So as long as the start terminal is the same, the running total would just go and get the sum or of each of the duration seconds. Okay, do you follow? So while this is the same, it would just get the sum for each of the rows. Now, let's see, once it encounters a different start terminal, it would actually, where was that? Yeah, there we go. It would restart. So boom, this is the last row for 3100. So this is the running total for that column. And then, so this is a new terminal. It would start all over again. Do you follow, guys?
Oh, so almost so when you do partition, it's almost like the opposite of earlier when you just
Yes.
you order
Exactly.
by, right? Because
Yeah.
it's now it's as long as it's the
Um,
same, it will keep stacking.
it's not actually the opposite. So what you do with the order by is you're actually sorting. You're actually applying the aggregate function
So it what if
to the specific
inside the
sequence.
over parenthesis over here, instead of doing partition by, you're doing it by order by star terminal. What your running
Um,
total will just be the same, right?
it will just be the same. Like for example, this all of this 3100
It will just
will
give
have
you that last final one. It will just give you that final
exactly.
one.
Yeah,
Got it.
that's what would happen, Jeff. You're correct. But notice we do have an order by here. So the order by paired with the partition by actually just identify the sequence and how the aggregate function would be applied. So let's explore that. So we have hypothesized that if we do order by here and multiply this thing, it would just give us the total for all of those with 3100 start terminal, right? And that's actually what would happen here, just like what we observed earlier. So this is the running total for all of those with 3100, right? So the moment we encounter a new start terminal, boom, um, you would get immediately the total for that terminal. Do you follow?
Yeah, I think I do. I think I do. So like if
Yeah.
we go back to that example earlier when you had the time, like the start time, whatever, and we saw that 2A78, and
Mm,
if that case you were using partition by, then those two A7 it will not be the same.
yeah.
You will actually, but then what's gonna happen is that all the other ones will just restart. It will not give you the
Yes, it
running
would
total. It will
restart.
restart.
Yeah, it actually sees the start terminal as a categorical thing, that it's a
Interesting.
grouping. Yeah, it's a grouping. It recognizes it as a grouping. So these are the partitions. So this is one partition, right? 3100 is a one partition in which the running total would be applied to, and the 31001 is another partition in which everything would
Ah,
restart.
okay.
Yeah. So it would start from the very beginning again, because why? You have the order by right here. So it start from the very beginning right here, at the very start that we observed 31001, and then do the adding up by sequence again of um start time. We haven't shown here the start time, but we can actually do that.
It's like a
Insert.
group by and having for the
Yeah,
display then.
it's like a group by for like applying the aggregate functions in groups. Okay, in groups. And that groups are considered here as partitions. Yeah, we can see that. Okay, we reached the limit for the memory, but yeah, you can easily see that with the start time. Okay, but I think everything is clear what's happening under the hood, even without showing the start time here. So remember the thing that when we apply the average for different genders, you're basically doing the same thing here, but you're using it in the select clause. You're doing the computation in the select clause through the window functions.
Sorry, Jeff, what was the one that you just ran before this?
Yeah, the one with the start time. Was it start time or
Well, which one was that?
this one? It just adds that column for the start time.
Oh.
Yeah.
But then if you partitioned it, right? No?
Yeah, I partition it. There's no problem with it. I just showed it like for each of these partitions for the start terminal. This is one partition. It refers to the start time. It
I,
actually doesn't affect anything.
I think Jeff was saying because the partition by start terminal order by start time. So why do you should have to show start time as a column and then put order by start time as well?
Ah, I see. I see. Um, well, sometimes you may want to see the um. Let me see. Let me see if I got completely the thing. Okay. So the question was, why did I also show the start time column if I use it in the order by, right? Was it the
Well, I
concern?
mean, I don't. Sorry. Oh, okay, I see it. Because this one you did both partition by and order by inside the parentheses.
Yeah, yeah.
So
It's
essentially,
going together.
what it does is that for the partition side, it just basically means that for all the 31000, it will keep stacking. But because you also added the order by start time,
Start from the
it,
very beginning of that start
that
terminal.
causes line 4 and line 5 to be the same.
Line 4 and line 5.
Line 4 and line 5 on the data that you had come out. Like, so you basically both become
Ah, okay.
1756.
Yeah, this one. Yeah,
So
because
if
we
you
have.
didn't, so in this case, if you didn't have the order by start time in there, you just had the partition by start terminal, then that those two lines would not be the same. They would just be.
Yes, yes.
It's because you
Um,
had the order by start time in there.
yeah, I have the order by start time in there. So the sum is being applied by the start time, right? In each of the groupings, in each of the
Right, right.
partitions. So imagine this the 3100 as just one partition in your data set. And it will just do the thing that we do earlier. It will look into the start time, start from the very beginning, right? The very first start time, the earliest. It would add those things up. If it counters the same start time, it will just appear the same here, right? Even though you
So
have
if
different
you just take
jurisdictions.
that off, if you take that off and you run it again, it will. But then your start time will not be ordered. It might
It
be
will not be
going
ordered.
all over the place, right?
It will not be a running total, Jeff, if that's the case, right?
Wait,
It will
what?
not be a running total. Because when we do running total, we want to start from the very first and then add as we proceed along, right? It will be jumbled in a sense. It would still be a running total, but it's not organized. So you're not starting from the very beginning by start time.
Right. You'll keep it will keep stacking, but basically your start time may not be organized like this.
Yes, exactly, exactly.
But
So the
what if
order
like
by here,
what if I want this basically to look just like this, except I want line 4 to be not 1756, but to be like
different.
85 plus 424. What would I have to do to
So
do that?
885 plus 424 plus 447.
So essentially, line 4 right now is 1756, right? Because
Yeah,
that's the total of
1756.
885 plus 424 plus
Mhm.
447 together. But
Yeah.
what if that line 4 I want it to be different then? Like I want it to be just 885 plus 424.
Um. So
So that
you
would
don't
be
want to have like the same value here.
yeah. What if I don't want the same value, but I still want this order the start time to be ordered like this?
Let me see. Hmm. Well, assuming that let me first think if that's possible, because what I did earlier is I used the row counter, but the row counter doesn't assure us that what goes in the first would be the very
Yeah,
first,
you basically
the
would it might not
earliest
be
start time.
time, but based on
Yeah,
the order of
it
time,
might
right?
not be time sorted, right? Let me think. Maybe we can look into um the table. Let's look at the table first before we try to see if we can tweak the query at the top um, to accomplish that. So basically, the reference should be the one to change, right? So currently, the order in which the sum is being applied is by start time. So we should look for another basis in which it's still ordered, like from the earliest one to the last one, by partitioned by the start terminal. Do we have that in here? So the end time should be different if like they have the same speed, right? So there are also replicates in there. Hmm. So in terms of table, I think we can use anything there. So let's go back to the query. Okay. So what we want, let me put it into writing to make it more clear. You want to show your running total that has no replicates in the rows. Yeah, just no replicates. Let's look at again that result that we want to revise. We don't want this, but the duration seconds, you cannot use that column because there are replicates and it's not based on start time. Hmm, is it possible here? Order by start time. what we can do is this: order it by start time. This is just a theory, okay? This is just a hypothesis. So currently it's ascending. What we can do is partner it with duration. Hmm, let me see. So order it by start time, ascending, and is this even possible? First start time.
Would it make a difference if we flip the partition by and order by?
Yes, there would be a very very large difference, Jeff, because if you put the start time in there, there would be too many partitions.
So I'm saying like if we do over order by start time first, then partition by start terminal, what would that be?
Um, order by first. We can try. Yeah, but I think it would throw us an error. It would be order by this first, right?
Yeah.
And then after that, partition by. So basically, it would first apply the sum ordered by start time and do the partitioning by start terminal. Hmm.
Oh,
Yeah,
error.
because
Yeah,
it
never mind.
doesn't. But logically, it should be the same, right? You apply the sum by start time, and then you just group it by partition by. Well, I think it just follows this specific ordering. Well, SQL
Yeah.
is known to be
Maybe
like
maybe
that.
there's not a way to do it, I guess.
Maybe there's a way. Well, we haven't really just thought about it carefully. We can just easily drop the ball that fast. Hmm. Currently, it's ordered by start time. It's sequence from the earliest to the last. But at the same time, I feel that we can add further here that it should be in order of duration seconds here. That's also ascending. No, it doesn't make sense because the duration seconds are clearly it's not
Yeah, maybe because I mean it probably doesn't matter that like but if they're going at the same time, then it should be counted like it just as one big chunk, probably.
yeah.
Yeah,
But
yeah,
practically speaking, Jeff and the group, to me this is not a problem really because well ah wait, I have an idea. What if we use the ID? Because the ID is unique, it's ascending. So start time, yeah, I think this would work, Jeff. I think this should work.
oh, there we go. Yep. It does.
Okay.
Perfect.
I just remembered that we have a row counter. Why not use that, right? Okay, let's see. 52, 74, 365, 885, 152. Yeah, perfect. This is it. You don't have any replicates here. These are also looking at the ID.
So just yeah, use both of them, and so that way we can have another
Yeah,
separator basically.
yeah, another
Awesome, awesome.
separator. So since the ID has no duplicate, just thought about it that it's unique, so you can actually use it. So in that way, your rounding total would not have any like any same values. Okay. Yeah. So yep. So yeah, basically you can. This is sum, but you can also apply it with average, right? Um. Oh, I should do it like in a different. Yeah. Okay. Do it here at the bottom. It should work. Yeah, it works. So, well, well, basically this is incorrect because who wants a running average, right? We don't do that in practice. So I just want to say that yeah, it's not only the sum but also the average and other aggregation functions that you can actually use with this. Okay.
And Jeff, one other thing is that I
Mm.
feel like this maybe we already went with this, but like why don't we use uh I feel like I'm a little confused in the sense like why don't we use group by in this case where we have multiple
Yeah,
things that have been selected?
group by will just give you the sum for each of the groups. It won't show you how the values evolve. So usually when you analyze data, you want to see how fast the sum is or the total is um, um, moving either downward or upward, and what could, like for example in this case, if you think about it in a different context, if you think about it as like a price of an asset, what happened in like during March 14, 2020? Why do you have this very low or running negative running total or average price that are that was continuously decreasing during that time? So you want to see how things evolve with
But
this
like, how
thing.
come it doesn't give us an error? Because usually, you know how there are times where we try to do it. If we don't do group by, it won't run. It will actually give us an error. But how come it just lets us run
With
when
the
it just
having
runs?
like that.
Like without a group by, sometimes you know how like there are times where we have multiple selects on there, and then if we don't use a group by, it gives us an error. But like,
Um,
this case, it doesn't.
like
We were able to just run it like this.
uh, let me think. So let me try to replicate that error that you were saying. Um, like for example here, let's get uh, uh let's group it by start terminal, and then um having, I don't know. Let's not do any filters. Let's just select sum of duration seconds, and then start terminal. Let me see if this was your the one you're pertaining to. Yeah. So
Okay.
basically here. Oh yeah. Wait. Whereby we want to make it more pretty. No. So that we can see that okay, starting from 3100, this is the running this is the total. So if you do it this way, you don't see how values evolve because it will just give you like the total for each of the start terminal. So these are the partitions that we use actually. This is partition one here. This is partition
Oh,
two and
okay.
so
And
on.
if we do this without the group by, it will give us an error because it doesn't know
Yeah,
where it's. But then over there with the partition, you give it more of a clear instruction on how they should be summing.
yeah,
Basically.
yeah. There's also a way for you to not get an error, but remember that aggregate functions apply the computation in the base value. So if you do this, it will just give you
Oh yeah,
the
but I mean it
entire.
has the but you're only selecting one.
Yeah, it will just give you the total for all of the records here. So it's not really that useful. But this one is just exactly the same thing as what we're doing right here, but this is more insightful because it shows you how the values change over time through each of the rows that you have in each of these partitions that you have.
Essentially, by
Does it?
having the over, you're telling it how to sum, and it's just
Yeah,
like if you have a
the
group by,
sequence.
you're telling it how to sum. If you don't have the
Yeah,
group
yeah,
by,
yeah.
then or the over, it just doesn't know how it's gonna be summing the
Yeah,
stuff.
the group by it doesn't care, right? It just okay. What basically in programming, what's going on under like what's going on under the hood is if start terminal is equal to 311, do this. So it will while it's still encountering 3100, it will just add until it encounters a different one. So that total then would be recorded, and then you skip to another thing. We will do that in Python, by the way. So yeah, the just a side comment that
Got it,
that
got it.
thing, this thing that we're looking at, will be building it from scratch. We'll create our own program that, like, how do I say this? Runs to do this different processes, this different.
So essentially, if this query we just ran, if you don't have the group by, it just doesn't know how it's summing.
Yes,
Like what are
exactly.
the ways you're supposed to be summing it? And
Yes,
the one that above you did, you're giving an instruction by doing it over
yes,
partition by adding one on like as a running total.
yeah, and that's the advantage of window functions. With a group by, you cannot do that. You cannot tell it how it should apply the sum. But with
Mhm.
the window function, you can somehow edit that portion and make it more into how you would see or how you would apply this aggregate function to each of the rows. So for me, this is well deeper, but in most cases, people would just be asking questions related to this. So this is a more like a deeper analysis of the same thing. But basically, most of the time, this would be sufficient. Okay. So any questions from the others? Grace, Hasiba, and anything that you want to clarify? So you have more practice. You'll have more practice
Yeah,
with
for me,
John.
I think I just need more practice because,
Yeah, yeah.
like, for the first half, I actually like wasn't understanding the data for a little bit. So
Okay.
how,
Yeah,
yeah, John's very big on like make sure you understand the data before you start asking what you want to show. So I
yeah.
was like, what is the difference between these columns? I was trying to figure out. Okay.
Yeah. Actually, that's correct. The one that you pointed out, this I kind of jumped into this data set without looking and explaining the columns. I got too excited. So yeah, John would be like going back to this the table and explain, okay, what are the columns referred to, or what are these things these records are about. So yep, that's what you will do with the lab. So what I want to do with the lab, guys, is you ask um these questions and you explore together. Okay. The ideal is you have like a we have um say an even number of students, but I think John would could partner with the others so that it will be like in pairs. Try to ask so many analytics questions and try to explore. It's perfectly fine to get error, guys. It's perfectly fine. It's completely okay to look for answers online. We're not doing it yet, but since my lecture time is very constrained, it's just 2 hours. So, but googling is a skill in data science. Uh, there's no shame in doing that, but it's time consuming, yes, but the deeper the more complex your questions are, the more um, ideas and syntax or codes that you need to use. And you don't have to memorize them. You just have to develop the thinking that, yeah, how can I translate it to this kind of setup in a specific programming language? So that's what I want you to focus on during lab. Okay. Um, Try asking more questions. If you cannot, like maybe you invested 10 minutes or 5 to 10 minutes in just one question, and you can seem to find the answer. Look online. Like, what are the ideas in doing that, or things related to that? It's how we cannot enclose ourselves in just this materials that I'm teaching you. These are structured topics, but in reality, we need to expand. We need to discover more syntax, more techniques, and that would really help you. So, yep, I think that's all that I intend to cover for today. Yeah, it's almost time. So we haven't done any breaks. So before you transition to lab, please do a 10-minute or 15-minute break. You have a long time today. Enjoy programming. It's fun, for example, that you get the answers. Sometimes it's frustrating. There were times that you want to punch the monitor because you just can't seem to think of the solution. And in those cases, my friends typically do uh, uh, a smoking break, or how do you call that? Tobacco break. Um, one of my friends, he always has this tequila on the side because when he's really frustrated, you need to have that like diversion, right? Try to step back a little bit and relax. Problem solving is very typical in programming. One one comma, one dot could ruin your life. Yeah, we need to develop that resilience. So anyway, I don't want um hold you for that long. You can transition to lab after the break. So thank you very much, guys. I hope you enjoyed the session. For Monday, will be we should start with subqueries. That's very useful. Subquery is very useful. It would make your queries more complex, and you can accomplish so many tasks with it. So yep. Again, thank you
All
very
right,
much.
Jeff,
Bye bye.
take care of your eye. Make sure
Yeah.
Yeah,
keep it
take care. Feel
lubricated
better.
and cover it. Yeah.
Yeah, yeah.
Wear
Thank
an
you
eye
very much.
patch.
I would look like
You look
a pirate.
badass.
You're gonna have to, yeah, to heal it. So
Yeah,
yeah.
yeah. Maybe just a rest. I've been working too much this past week. So
Yeah, the screens
yeah.
don't help.
Yep. Thank you very much, guys. Again, bye bye.
Thank
Enjoy the
you.
weekend.
Bye.
Yep.
Hello, everyone. Can you hear me?
Hello.
Hello. So before we transition to lab, let's have a 15-minute break. Okay. So let's go back after 15 minutes. Hello, everyone. Are you there? Thank you for that confirmation. Wait, let me try some
I'm
stuff.
here.
Clearly. My voice clear. Just plug in my earphones and hoping that it will perfectly fine. Okay, so I think everything is fine. Let me share my screen first. I think the last time there are some problems about the activity, the lab thing. So some questions on it are a bit confusing.
Is anybody else having problems hearing John? Or just me?
Yes, me too.
You sound
You
very
can
muffled.
hear me, somehow distorted my voice. So let me Can you hear me?
Yeah, I think
I
now
I
it's
think I think the problem is the device that I'm using. So let me change my device real quick.
Okay, thank you.
Hello? How about now? Okay.
Yeah, that's much better. The other one had a
Okay.
lot of vibration or echo or something.
Okay. So I think it's on my other device. So I'm trying to use the other device, like a smaller version of my device that I'm using right now, because probably on the next days I'll be out of town. So I'm trying to use smaller devices so that it is easier to travel. But I think it would not be efficient, so maybe I will just use my laptop instead. Okay,
Or if you
so
do this small device, is it like a tablet?
yes,
Maybe we
I,
can try it later with like a attached headset. So it's a headset microphone, not tablet microphone, something like that.
so unfortunately in my tablet there's no dedicated port for the headset.
Ah,
Okay, so maybe before our session meeting, let's is it okay if we will try to find some solutions to that? I will try to switch to my tablet and let's see if it works for you. If
yeah.
I can, okay,
Mhm.
thank you for that. Okay, so I think based on the feedbacks last time, um, there are some problems on the last lab that we assigned about the lab 10, the joints. And let me guess the problems. Some of the questions are quite confusing. This is the things are that are the contents of the lab 10. Only 4 questions, but these questions are quite challenging. Later on, after we finish this lab 10, we will try to work on with the next activity, which is, where is it? This one, the lab 12. It is actually the lab 11, but it seems like lab 11 is joined with the lab 10. So lab 12, we will do it after the lab 10. But we will try to perform this first, the activity that was left to us by our instructor, so that we will have some practices about the union. Okay, so I think Jeff said that he already submitted the file about the lab 10.
No, I
So,
actually had some issues with the lab 9. I didn't finish everything, but
okay, lab 9.
like the last few problems. But I mean, let's go over. We can go over lab 10 first. And if we have time, we can probably.
Okay,
Yeah,
okay,
lab
so
10 was the one I missed. I missed that lab. So I was like, are these saying that each bullet point was like to do it separately or do one search with all these conditions? So I didn't understand
No.
too much lab 10.
okay. Uh, the first question, is it clear, or I think this one we already did this.
I think we did the first and second.
Okay, first and
So,
second.
yeah.
So we left with the third one and the fourth question. Okay. So let's try to focus first on the third question, and let's see. Okay, even me, I'm still confused with the questions on the joints. So maybe we'll we'll talk about it. I will ask Sir Jeff for some revisions of the questions to make it much clearer. One of the struggles of being, I think, on a standpoint of the educator about the programming languages, one of the hardest part is creating a question that is not vague. Like, you need to create a question that is very clear, very concise, in which you can deduce whatever is being asked. Okay, so let's try to deduce this problem. So before that, let's try to run the entire table. Select all from. We are using two tables here, right? Tutorial.crunchbase, investments, and companies. Select from. And the last time, we
I
already
think last
scanned.
time we used the companies and acquisition, not
Okay,
investment.
acquisitions. Sorry for that.
Yeah.
Acquisitions and companies. Acquisitions. And based on the last discussion, the last club session, before I missed the classes. So thank you for your understanding on that missed classes. It is very helpful for me to survive this previous week. There are so many things that I need to attend to. And I'm very glad that this week is over. So I can recover on the focusing on our classes. Okay, so the last time we have analyzed these two tables, the acquisitions table and the companies table, wherein we determined that the connection between these two tables are the company permalink and the permalink. Permalink. Permalink is located from the company's table. It is on the company's table, while the company permalink, it is on the acquisitions table. What else? We have observed the last time that not all companies have acquisitions. And we also observed the last time that there are companies with multiple acquisitions, or they are involved in acquisitions or transactions multiple times. Acquisitions. Okay, so the problem here is retrieve the name of the companies and their acquisition amounts, including the acquisition of companies that have been acquired for less than 1 million. Okay, let's try to see first what are the contents of each table. This is for the right table, right join rather, right join. So the confusing part here is what table should we consider to be the second table or the right table? Right, right join. So the puzzles goes like this. Selects. For now, we don't know what are the things that we need to select. But we have this. We also have this join. We also have the on. And we are sure that we want to join them using the company
The permalink, right?
permalink, permalink, and permalink. And later on, we will assign aliases on the tables wherein the company, I will just call it comp like this. And the acquisitions table, I will just assign an alias later as ACQ. So the hardest part here, I think, is deciding what table will be considered as the second one, the second table. Retrieve the name of the companies and their acquisition amounts, including the acquisition of companies that have been acquired for less than 1 million. Name of companies and acquisition amounts. Okay, considering this, the acquisitions table, we have here a column that is that contains companies that have been acquired. These are the companies that have been acquired. And there is a column here in which it contains the companies which are the acquirers. So we have two columns here. One is company that is acquired. The other one is the company who is the acquirer. We also have price amount in which I guess this is the acquisition amount less than 1 million. However, it asks us or it says that we need to use right join. So before that, let me find how did I perform this code. Let me see how did I did it the last time. Acquisitions. Okay, I think this one. For this question, okay. In this question, I think the heavier part is to use the company's table because the company's table contains all the names of all companies, even though they don't have any acquisitions, even the companies that have acquisitions, it contains all of that. It contains all of the names of the companies, this company's table. Okay, so that is the reason why the observations here are much bigger compared to the acquisitions table. So do you agree that in this question, we need to set the company's table as the right table? Because it
Yeah.
is the one that contains all of the names.
Yeah.
Retrieve the name of the companies. And if they have acquisition amount, you need to return it also. Also, all of the companies that have been acquired for less than 1 million. Okay, so for this, I think here, what goes here should be the companies. And I will use COMP to represent or to alias this table. And here, I will use the acquisitions and represent it as ACQ. So here we are joining acquisitions table to companies table using right join, meaning all of the elements of this will be included on this column, permalinks. And this alone is already a working code. So let's try to see what are the contents of this table. Okay, so company permalink. So I guess this first columns of our resulting table is from the acquisitions.
Is the permalink? Is there? What's the difference between the company permalink and permalink?
And the company permalink is located at the acquisitions table.
Oh,
While the
and for the
permalink,
company table, it's just called permalink.
yes, it's just permalink for
Oh, that's
the
why you're setting them equal.
Can you keep it
yes
on that? Let me run that on permalink equals.
permalink. On one of the codes that I did, I also use multiple connections wherein I used the to make the because as you can see if you on the joins, it takes a lot of time to run the code. So I also use the name column, and what else? The name column, and what's the other one?
Isn't company name and
Yes, company name and the company name and the name. Okay, so it looks like this. ACQ dot company name equal to com dot name only. Like this. I don't know if the runtime was decreased, but I think by using multiple columns, it will somehow reduce the runtime. So this alone is a working code, but we need to extract only specific things. The name of the company, the acquisition amount, as well as we need to filter them whether the amount is less than 1 million. Okay, so we can add the filtering after the on where price amount is less than 1 million. And here we want the company name, comp that name, while what's the other one? The acquisition amount. So ACQ that price amount. ACQ the price amount. Oops. So let's see what would be the result after writing this code. There's only 8. Is this correct? Wait, let me verify it. This one is also confusing in my part, to tell you honestly. So I think there's a need to revise this set of questions. Even in the previous cohort, less than, greater than, it should be greater than.
But also, if it's less than 1,000 or 1 million, shouldn't you just return a lot because there's a lot of empty ones, or the empty ones just don't count as a number? It's because they're null, they get excluded. Is that what's happening?
I think so. That is what's happening here. That they
Right.
are not, that they are not presented. They are not counted as 0. So we don't know. Maybe it is just a missing value, and the actual value on that is higher than 1 million. So maybe that's the case. Let me verify the question. Where did I get the greater than 1 million? It's for the number 1. The
This is
number 3 is
less than 1 million.
less than. So the last time that I did the sequel, do you still remember the last time that we met? The I think that's Tuesday. So okay, I think we have the same set of codes as I did at the last time. Company name, price amounts, and there are only 8 on the result. 8 companies in which the acquisition is less than 1 million. So I think it's possible because a lot.
Because it's excluding all the ones that were not being acquired. Like with the null,
Yes,
it just
yes, yes,
didn't count those, right?
yes. And also, majority of the companies included in our data set are big companies. So 1 million is,
1 million is pretty small.
yes,
No.
pretty small for an acquisition. So maybe that's the reason why we only get 8 companies with this acquisition less than 1 million because of the scale. Okay. I think this is also the way we solve number 3, the lot on the last cohort, and it was solved by the instructor because uh I need her help because I'm not sure if my code is correct, but it seems like we have the same thought of the code for the number 3. I think the number 3 is the most difficult among these 4 questions because the number 4 question is pretty straightforward. Because if we will take a look on it, find the acquisitions and their corresponding company names. I'm not sure what is the column that pertains specifically to the acquisitions. I'm not sure if this is the amount or not, but if we will consider it as the price amount, there's no problem. If this will be considered as the price amount, we can just extract it using the select clause. But what's important here is the way we will join. We will join the table. Here it says full join. So here we don't have any problem whose comes first. It's a matter of preference who who do you want to see on your results. So it looks like this. Like on this code that I did the last time. So we are joining the companies and the acquisitions using the full join. The full join. Okay. On the same permalinks, on the same columns. So now I will just select all and let's just observe what would be the results. So here, there are just this things that are enclosed in parentheses, they are just descriptions of the results. Oops. So let's see. Because not all companies have acquisitions, we can see a lot of leasing values here. It is caused by the full join. And since not all companies have, or not all companies have acquisitions, this is the result that we should expect. Not for the acquisition details of those companies without any acquisitions. And acquisitions without a corresponding company, since upon analyzing our dataset, there are no missing company name. So we will not observe these types. Like there are what they call this, there are details of acquisition, but there is no company names. Okay. So this is very evident because we have a lot of companies, but only several of them has acquisitions. Even on scrolling on the first 100 rows, okay, so there are so few of them that have acquisitions. Like there are only 6 in the first 100. So those are very small numbers. That's why majority of these are null values. And we after this, after you join them, what is left is we need to select the particular columns that is being asked. So find the acquisitions. I'm not sure what is this acquisition. So
I wonder if
let's
it's just the acquirer and then the company name.
okay, acquirer and company name. Or
Acquire, and I mean acquire and then the price. Acquirer
acquirer
name and the
and
price, and then the corresponding company name is probably the company being acquired, right?
okay. So we have acquirer name, acquirer name, the company name, and then the price amount. Like this.
Yeah, I'm guessing.
Okay. And the total funding amount. So there is also another column, total funding USD. This comes from the company table. This is from the acquisitions. This is from the acquisitions. Also, this is from the acquisitions. So this is the only thing that is
Wait.
different from the rest.
What about the company
Hey.
name? Is that in both? That's in both, right?
No,
Yes,
the company table doesn't have it as company name. It just has it as name.
yes, name.
Okay, as a
Name
name.
only.
So when you do full join, you don't have to tell it which table to get it from?
Can you repeat that question?
If you're doing full join, you don't need to tell it which
Okay.
table this column is coming from.
So the thing is, I think this one it will still run, and the reason is they don't have any same names from different tables. Like from those two tables, these names are unique. However, it will become problematic if table A and table B both contains column, like for example name. Both of them have column names as name. There will be an error. It will give us an error, which means that which says that column names are ambiguous. So SQL cannot determine what table exactly do you want to extract this column. So in those cases, we should indicate what is the table you are referring to, and what else. But in this case, if they have a unique value, like unique column name, it is safe to just write it this way. That is only true for joins. Okay? Because on the next topics that we will discuss, we have subqueries. What else?
Actually, in
Um,
that case, should we be using the name instead of company name
tables. We
for
can
the
also do
select for
that.
the second one?
We can also do that. Name. And I think this one will give us much many results compared to the other one. Like this
Okay, yeah.
What's the total rows you have there?
total. Okay, so the thing that I'm talking about a while ago is about the subqueries wherein specifying where table that particular column came from as nearly a requirement. It is a requirement. Like to be safe, every time you will call something, even if that is a column or that is a table, you need to give it an alias so that it will determine, it will be clear for SQL that you are referring to that specific column or specific table. Because on the subqueries, it's possible that you will use two tables that essentially they are the same table. Like, do you still remember the concept of self-join, like the last time? Okay. On the self-join, we are using a single table, but it is somehow we are creating a duplicate of it, and we are calling, we need to assign names to both of them differently. Like, just a simple table 1 and table 2 will do. But on the actual practice, we should give them meaningful names. And I think that's for questions 1 to 4. For the number 3 and 4, I will leave the choosing of the actual columns that you will choose. The thing that is important here is the way you join the table. Okay, the way you join the table. So when I check your works, it doesn't matter what are under the selects. That would be the consideration that I will give on this problem, on this particular data set. I will try to return all of the scores this coming week. Like before the next Saturday session, I will try to return all of the grades with detailed explanation why did you get that grade. Okay. Any questions on the lab then about the joints? Or is everything clear to this point? I think everything is clear on the lab
For
number 10.
for running number 4, there's like a lot of empty boxes in here. Yeah, I got all of nearly price amount was empty, acquire name. Is that the purpose of the question?
Uh, Not really. The purpose of the question is to yes. Sorry for the confusion. Uh, it the thing in the full join is it just wants us to see that the results, it would contain a lot of missing values, and especially those companies that doesn't have any acquisitions. Like these companies, they don't have any acquisitions. That's why this one is empty, and these things are also empty. There are also acquisitions wherein the acquirer is present, but the price amount is not. Usually on full joins, the thing in the full join is it will stack your data set perfectly. It will not throw any data set, any data rather, However, the problem in that is it would introduce a lot of null values in our data set. Let me show the visualization that I showed the last time. I think this one. While you are away, Grace, on the previous meeting, I'm not sure if you have seen this practice or you have seen this visualization that I prepared. So we have the first table which corresponds which contains data order details ID, order ID, pizza ID, and the quantity. And we have a second table which includes the order ID, which is essentially the same as the second column. And the second table contains the date and time in which the particular order happened. Like this is the way we should interpret this. Referring to the second table, order ID 2, let's say the customer number 2 of our store in that particular day entered at January 1, 2015, 11:57 a.m. And that particular customer made 5 orders. So customer number 2 made 5 orders. In our data set, it will be recorded 5 different times. So all of them have different details. So we will assign different IDs in there. And each of them has a special characteristic like it's classic deluxe, 5 chills, Italian super, and so on. So suppose we want to view them like a single table wherein we have the order details, the ID, pizza ID, quantity, as well as the date and time when the order happened. So that is the purpose of joining them. So if you use inner join, it will just return us everything that has connections with order ID and this order ID stuff. Like everything that is not here, everything that is not matching from this column to this column. Wait, my Excel is acting weird. Let me refresh it. Everything that is not connected from this column to this column will not be included. Like our order ID on hand is up until the customer 25. But on the order details ID, I made it in the way that we have here the customer 26, 27, 28, 29, and 30. So if we will use inner join, we would not see numbers 26, 27 up to 30. We would just see up to number 10. Okay. And it looks like this. We use inner join. So both matches, only matching records from both tables will be returned. Unlike using left join, wherein if we will consider this as the left table or the first table, everything that doesn't have a match will have a corresponding null value. Okay, so the first table is everything is this. However, for customers 26 to 30, we don't have any data about their date and time. So if we apply left join, it will have null values like this. These null values are caused by join, not the data set itself. Okay, so we should be wary of what is the cause of the null value. Is it caused by is it the nature of the data set that we are handling, or it is just induced by the join? Okay. So on the right join, it works on different way like this. The order ID or the right table is complete. So the order ID, if you would take a look into this, it is until 25, until the 25th customer. However, on the order details ID, we only have details for customer 1 up to number 10. All of the details of the second ID is returned like this. However, this portion of the table doesn't have any match. That's why SQL created null values for it. If you will apply right join there. Okay. And if we will take a look on the full join, it is like a combination of the left join and the right join. Like it would look like this. So everything at the top has connections. Okay, so that is the part of the inner join. And since we are using full join, everything on the first table will be returned. However, the catch is it it will be matched with null values. The same thing as the elements of the second table that doesn't have any match. So it will be filled by null values. So the last time Jeff asked the question like, why don't we just use full join? Why do we need to use inner join, left join, right join? Why don't we just use every time the full join? And the problem in that is, as you can see, it introduced a lot of null values, and analyzing data with a lot of missing values is tedious. It can affect the analysis and as well as the result. That's why full join is not always the best choice. Other joins are existing. The same case as the inner join. Even if inner join will not introduce any missing values, but the problem is you are losing data from both the tables if there are existing details that doesn't have much. Like after the inner join, we lose the data about the date and time of customers 11 to 25. We also lose the order details of customers 26 to 30. So it is a data loss. And take note that every data that we are losing, it corresponds to a cost. Literally money. Every time we lose our data, it corresponds to a lost money because collecting data is expensive, especially if we will do a survey. Like suppose you are surveying 400 respondents, and after you collected the data and upon cleaning it, you lost 100. And to think of it, those 100 people that you asked to answer the question, let's say you give them a token, each of them, let's say $1 token. So it is already $100 of loss. So it is a simple example, but data loss is not always preferable. Yeah, it depends on how much do you how much do you afford to lose. Okay. And sometimes the problem is if you lose too much information, it can also affect the results. It would result to, let's say, overestimation, underestimation of the measure that you are interested. So just some few sidelines like I'm sharing that is somehow connected to the joins. Okay, so maybe we can proceed to the practices or the practice that is about the union before we proceed to the lab. But before the actual lab, let's take a look on the concern of Jeff about the lab thing. Okay, let's try to answer this question or to perform this union. Okay, write a query that appends tutorial Crunchbase investments part 2 to Crunchbase investments part 1, including duplicate values. So if we want to include duplicate values, what do you want to use? What do we need to use? Union or union all?
You
Union all. Okay. So
know.
I will just
John, is this from, these are screenshots from the lecture, right? That
yes,
we're doing? Okay.
this one. Let me send it, or I think I already sent it on the chat box.
In the chat.
But I will just paste it again because it is already crowded by other messages. Okay, so let's try to do this. Tutorial Crunchbase Investments Part 1 and Part 2. But before that, let's take a look whether we can really join them. We can really join them because it is already stated that we can join them, but we should verify it. Select everything from tutorial that Crunchbase Part 1 as well as the Part 2. Part 4 should be Part 2. So Part 1 contains these things. On union, what is important is, based on the discussion, they should have the same columns. What else? Data types under each columns and the order of the columns. These are the things that we need to check whether they have the same ordering, they have the same data types. When we say data types, is this column contains a string? The one that you will join on that should also be a string. You cannot join two tables, which the first table contains a string on this column and the second one contains a numerical version of that. So we should check its data types as well as the order of the columns. It should be on the part 1, it is company permalink followed by company name, then category code. On the part 2, the arrangement should also the same, exactly, without any differences. It should be company permalink, company name, as well as the rest. So this is for the company. This is for the part 1. So let's check the part 2. So this should be, they should have the same columns because it is already a practice, but on actual doing of the union, this is the first step to analyze whether the columns and the data types and the ordering of the columns matches perfectly. Okay, so they have the same matching data types, ordering. So there's no problem. There is no thing that hinders us to perform joining on this tool. Select everything from this. Let me just retype this way, and we will just apply union all like this. So that's the only thing that is added, union all. And we should after applying this, what happened is, if this is 30,000 records, 30,000 rows, and this is 40,000 rows, after applying union all, if you run everything and count every row of that, it should contain 70,000 rows. So literally, we just added all of the rows because we are using union all, and in union all, duplicates are allowed. Unlike the union only.
Why would we do that actually? Or is it just there? But people usually just use union instead of union.
Preferably, union all is much useful because commonly we don't need duplicate values. So like if record 1 is exactly the same as the record 1s, and duplicate values can give us problems. Like it seems like there are many, for example, on grading sheet of a teacher. Like there is a student that is very smart, that his grades are very high, and imagine duplicating those students. So it would cause the grades to be pulled upward because the grades are so high. So in that cases, we don't need duplicates. I on my experience, even if that is just a short experience at this point, I never encountered an analysis that includes duplicate values. Literally, all of them they want
So but
a
it,
unique.
so doesn't that mean that people usually use union more than union off?
Yes,
Okay, okay.
union is much useful and it is much commonly used, even if not using SQL, even if they are using different softwares. When they are combining data sets, they are using union much commonly. So the only difference is if you use union, duplicates would not be included. So what we mean by duplicates is they are the same for each column. Like for example, imagine on the Excel, let's do it this way. Imagine you have name, age, um, grades or salary, position, and you have the same inputs to all of this. John 22, salary, let's say 100, and let's say TA. And you have this. So what we mean by duplicate values is these are two different rows, okay? Two different rows, but on every column, they have the same inputs. That is the meaning of duplicate values in the sense of a tabular data. Two different rows, or let's say three, let's add another one. Let's say three or even four. Four different rows, okay? Four different rows, but on every column, they have the same inputs. That is what we mean by duplicate values. This one is not a duplicate values. Let's say this one is Dave. Even though they have the same inputs on three columns, one is different. So it is not a duplicate value. This row is different from the other rows. But this one is identical. That's why on big data sets, even on simpler data sets, commonly we always see a unique key identifier that there are different codes on that, like this combination of different numbers, also letters, like it represents like they have the same name, they have the same age, they have the same salary, but these two persons are different. So by adding that key column, somehow this row is different to this row. So the software can determine that they are different. Okay. So especially when you are handling a very big data. So the probability of having two rows that has the same inputs is somehow high. Is somehow high. So that's the role of the keys in the sense that it can eliminate or it can reduce the duplicates in our data set. Maybe these four gens are really four different peoples. They are living from different countries, It is just a coincidence that all of them have the same information like this. Okay, so for the union everything, let's suppose all of them are the same. All of them will be returned. But if you use union only one of them will be included in the result. So as simple as that for the case of union and union. Going back to the problem, filter the part 1 table to include only companies that starts with letter T. So referring to the part 1 table, we should filter this in which everything, what's that? The company names will start at letter T. Okay. So how can we do it? So suppose that this one is the table 1. This is the table 1 only. And we are interested with the name. The company names starts with letter T. So how can we do it? So the company name, how can we represent in the language of SQL the line, the name should start at letter T? What's the tool that we need to use?
Equal?
It equal? Okay, what's the following?
T?
Okay, like this?
Later. Yeah.
Okay. So if we do this, it is somehow interpreted as on this column, I want only all the things that is like this. Letter T. So it will just give us all of the companies that is named as T. And since there
Would you
is
use
no
like?
okay, like okay, continuing to this, since there is no company that starts since there is no company whose name is letter T, it will not give you any results. So this problem is focusing on pattern matching. Like I want the T to be the start. So phrase is correct. We need to use like. Like since T is the start, what's the missing part here? What's the missing puzzle? Company name, like, okay, what's the code?
The percentage sign after the T.
After, okay, after the T. But what if there are companies that starts with lowercase letters? Like there
like.
are okay, I like. So we are using I like to be sure that even if that is a lowercase t or an uppercase t, it would give us the company. Okay? So that is for the filtering of the part 1 table. How about the filtering of the part 2 table? Let's see. Part 2 table. Okay. The part 2 table to include only companies with names that starts with letter M. Both are not case sensitive. So we actually applied the canceling of case sensitivity on the first one. So we will just repeat it on the second table. On this, we want only the companies which names starts with letter M. So the same concept as this. Okay. We want the company name with I like M. Is everything clear to this point? Did we break down the
Yeah.
questions? Okay. So
Yep.
we break down the questions at so its simplest level. So it succeeded. So let's see if this would give us the row counts that we want. Okay, it ran. And there are only 4,883. Wait. Union practice, including the duplicate value. So we missed this part. So we need to use all. I think I write it earlier, but I remove it when I'm explaining the difference between union and union all. Okay, so this should give us, if there are any duplicates, this should give us a higher value. But I think there's no duplicate values on the part 1 and the part 2 database. That's why using either union all or union gave us the same number of rows. Okay? Even if you are using union all, if there are no duplicate values, the counts will be the same as simply using the union. What else? Include only the company permalink, the company name, and the investor name. So on each of them, we will type company permalink. What else? Company name and the investor name. Investor name. And if you are selecting specific columns, if that is the arrangement you selected, the columns on the first table, that should be also the arrangement. You will type every column on the second table. Is that clear? They should have the same arrangement.
Yeah.
Okay, so that are the things that you should take note of the unions. They should have the same arrangement. They should have the same data types.
Makes sense.
Because like the demonstration of Sir Jeff earlier, if there are no matching or even if you are selecting the same columns but the arrangement is different, it should give you, oops, this actually work. The reason why is company name and investor name have the same data types. However, this is problematic because your data set is now a mess. You are mixing company names to investor names. Okay, so the catch here is they will work even if you mixed the the columns as long as they have the same data types. Like, okay, focus on this. This is a string. This is also a string. So it's possible to switch them up. However, that is problematic because you are you are now using a not reliable data. But suppose you have, I think we have ID right on our data set. So let's just add IDs. ID is in the first on the first table it is in the first, but on the second it is on the last. So let's
John, mine is not working. Can you take a look?
Okay.
Share
Okay, sure.
my screen.
Okay, sure.
So it says the error near where.
Where? There is
Yeah.
an error near where?
I think you had an extra. You had an extra semicolon.
Okay, okay, okay,
Next to the part 2.
okay,
Oh,
semicolon.
yeah.
Okay, and I think that will work.
Okay. Thank you.
Okay, okay. So it's actually solved. On the last
Yeah, that
cohorts,
happens to me a lot.
yes,
I was like,
that
why does it?
happens a
Why I
lot.
was like, oh, why do I have an extra? Sometimes it's like an extra comma.
Yes, that happens a lot. And there is a funny experience that I experienced during my, I think that was on first year, second semester, wherein we are learning the C++. If I don't know if you are familiar on that, or somehow you heard that programming language, but if it is a programming language that I found it very hard. So on one of my activities, so let me share my secret. On one of my activities, it said that you need a semicolon on the line 39. You need a semicolon on the line 39. So I am working with the code with hundreds of lines. So I go back to the line 39 and it says you need a second semicolon. But looking at the line 39, there is already a semicolon. However, it is not working. What I did is I put another semicolon, run it. It encountered an error. I deleted it. I ran it again, and it worked fine. Sometimes, programming languages I can't understand it. Like it already have a semicolon, but it asks you for another one. And when I gave it, it doesn't work. When I remove it, it works perfectly fine. So, just a side note of the confusion that I experienced learning some different programming languages. Okay, going back to this. On the first row, we have a numeric value. We have a column which is numeric. But the first column on the second table is a string. And it says union types, integer and character, varying, cannot be matched. Okay, since you are matching an integer to a character, it will not work. But if you have two different columns in which the other one contains a string and the other one also contains a string, just like company permalink, this is also a string. You mix it up with investor name, it will still work. So in those instances, you should be wary of your codes because even if it work, doesn't mean it is correct. Yes, it worked perfectly fine. You did not encounter any errors on your code. However, the result is not reliable because the logic under the codes are there is something wrong. And in every analysis, garbage in, garbage out. So if you will use wrong data, the result would not be reliable. Even if you will use very complex models, even if you use uh, algorithms that are very advanced, since you use uh, a data that is not reliable, the result would also not be reliable. What else is okay? I think this one is pretty straightforward. You filtered the first one, you filtered the second one, you joined them, and we just extracted the specific uh, columns on both of them with the specific arrangement. Okay. In R, if you will explore it on language, R language is commonly used in statistical analysis and also on data science, data analytics. But based on the based on the different tallying and data mining results, Python is the number one tool and data science, then followed by R language. In R language, there is this concept that we are talking about. It is called row binding. Row binding. So literally, you are binding, you are combining the rows. And the requirement in that is the same as this because the concept is the same. They should have the same columns, data types, and order of the columns. But in R, even if you combine numeric into non-numeric, it would still work. However, the numeric one, the numeric values will be converted into strings. And that would result into a data loss. Because sometimes it will just become null values or NaN or Na not available. Some representations of null values in different datasets. That is called row binding. The joins on the under the SQL, they are called column binding. Because in the joins, right, you have 7 columns on the first table, 3 columns on the second one. Literally, you are connecting the columns based on a specific column that have matches between those two tables. Okay. So some additional information about this topic. But I guess we can proceed to the next lab. So we will go back to the lab 9.2 after we take a look on the lab 10. So let's take a look on this. Oops, I actually downloaded this is not the correct activity. I will publish now the union and self-train activity. And let's set the due date on. Today is Saturday. Maybe before the next lab session will be 19, so maybe Tuesday. Oops, or Wednesday on our end. Starting today is available and the deadline will be okay. Let please confirm if you can see it. I just publish it now. I remember this activity that it is also challenging, like the lab 10 and 11. So let me know if you can open the file so that we can proceed on working on it together.
So it's not available yet.
Not available yet. Check. Edit.
Mine is available, but it doesn't have any file.
That's odd. Wait, there's a lab 12 docs file available from I set it since yesterday on the other day.
Yeah, it's showing us upcoming assignments.
Okay, please check it now. It's already updated. Available from May 17 to 22. Let me see it on the students page. Hmm. Already, it is already May 19. Why it is not available yet? Is let me restart this. Available from May 17. It's very clear that it is available from May 17 and due on May 22. Not published. Okay, if it will not work, I will just send it on the Discord.
Still not working.
Oops. I sent the file on the Discord, so check if you can access it. Use the red colored questions answers to get an idea on how to
There's
prepare a
probably like a YouTube or Google as to how to get the document released when you publish or something.
Can you repeat that?
Oh, I was thinking there's probably a way to, there's probably like a Google or a YouTube as to how to really, because it's like, it's showing as a newly assigned assignment, but then the attached document is not released when you hit publish. So there's maybe like a missing step or something.
Let's find it. File upload limited. Assigned to everyone. Available from what date is 19, so I will just set it into 18 or 17 to be sure until I to reach some buttons here. Let's see the student view. If it's not working, I can't understand. It should be available since May 17. It is not available yet. But on the other activities, it worked perfectly fine. How to make files on Canvas or assignments.
How to publish assignments, attachments,
How to publish.
not working.
Okay, let's see. They should be green checked. Let's see if that is checked. It is published, so it is it has a green check. Viewing individual assignments. Publish and publish. Let's see this one. Or maybe I will just try to add another assignment. Before that, let me copy the one in the lab 12. I will just create another tab for assignment. See what's the problem. Let's document, the document.
This assignment is part of an unpublished module and is not available yet. Oh, maybe you publish the assignment, but not the module.
Okay, maybe that's the case. Let's check. The same problem like the last time, maybe. This one should also be published. Where is it? Joins. Oh, okay. I think that's the problem.
Aha.
Maybe that's the problem. Okay, please check if you can access the files now. Maybe that's the problem. That's why it's
Here
accessed.
it is, Lab 12 doc.
Okay, I think that's the problem. Thank you for pointing that
So
out.
it's still saying upcoming assignments.
Hmm.
I just
Wait, hold
downloaded
on. Let me see if it's a word.
Okay, can you try
Well,
to
actually, it
refresh
works.
it?
It works. It works now. It works.
Okay, okay. Sorry about that. Okay, let's try to work on it. Maybe at this point, you know, what's my strategy whenever I'm answering this type of questions? I try to break down the questions in the simplest way as possible until I can understand its meaning. Okay.
This Lab 12 has red font. Yeah, okay.
Yes, has red font. There is a note on the lab 12 that says if you can answer the questions, you can use the solutions. This this part to get an idea on how can we answer the other questions. This is also 4 questions. And maybe let's try to practice next time the suggestion of Sir Jeff wherein I will oops. I just remember it. I cannot pair you in two because you are three. And maybe the partner of the one on you is me. If we will do that setup. But okay, for now let's try to stick in this setup that we are doing right now. Okay. So please use the tutorial Crunchbase investments and tutorial Crunchbase companies. And we need to use subjoins here. Okay, so let's try before we, as usual, our drill, before we dive into analysis, let's try to see first, let's try to familiarize first ourselves on the data sets that we are handling. Though we already saw what are its contents, but it's a good practice because sometimes you would forget what's the concept, what are the contents of it. So let's uh this part. Investments. Okay, so the new data set to our activity is the investments. The last time we are working on the companies as well as the acquisitions. Now we are introduced into a new investments into a new table which is named as investments. So for now, let's try to understand what are the contents of the investments. Probably almost the same as the acquisitions table, wherein there is an investor, there is also a company. Let's limit it by 10. Maybe it's having a hard time telling us the result.
Can you please zoom it a little bit
Okay,
here?
sure.
Yeah, thank you.
So we will just analyze first. We will try to understand first what are the contents of the investments. We have the permalink, pretty much the same thing as we observe on the Crunchbase acquisitions, permalink, company name, category code, country code of the company, general information about the company, investor, followed by the general information about the investor, the funding round type, and funded at. And the funding date is broken down into months, quarters, year, and we also have raised amount data. So maybe you are wondering why this data set, like it is also a side note, why this data set needs to have a quarter, a year, a month, even though it's already have a date in which this column contains everything. So since we have month, quarter, and year, we can actually use this data for time series analysis. So that is actually part of advanced stuffs data analytics, but we are analyzing in that concept. We are using historical data in which it is recorded like daily, monthly, weekly, yearly, and using that, we will try to predict what would happen tomorrow or what would happen next month. So that's the time series analysis. So, like for example, the number of COVID cases this past 3 months is this, it is increasing. So next week, if we will not do something, if we will not do any changes, if we will not induce any restrictions, what is the expected number of COVID cases? That's why there are forecastings that if we will not do something next week, there would be an additional 80,000 new cases of COVID 19 cases. Or if you are if you are always watching or listening to newscasts, okay, we are always on the part that there is this part called weather forecasting. Like they are saying that tomorrow there is a 80% chance of raining heavily or 80% chance of having thunderstorms. So they are actually using previous data to predict what would happen tomorrow at a certain degree of certainty or probability. It is not always correct because there's no perfect prediction, but at least you are uh, having you are having a glimpse of what would happen tomorrow based on your historical data. And that thing is pretty useful, especially on businesses. Like for every second week of December, you saw that your sales are going high. So what can you do before and after that second week of December happen? Okay. So going back to this data set, we have company followed by columns about the company itself, and then investor followed by general ideas about the company, the investor itself, then funded at, and then funding round type. I think that are the things that we can use for this data set. So going back to this, which companies, so company names, have received investments from the same investor name in multiple funding rounds. So we need to find companies. So if we will try to visualize it in the data set, we have a column of companies. We have investors. We have funding round type. Suppose you have this simplified version of the data. We have company A, B, C, and D, in which the investors, wait, same investor. How can I visualize it? Let's say A and B, 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 C and D. C and D. So let's say I am the investor of the first one, and let's say Jeff is the investor of the second one. And let's say Hasiba and Grace is for companies C and D. And there are different funding round types. Like on our actual data set, there is Angel, Series A, Series B, others. Let's say on my end, I used Series A, and Series B. Series B, where Jeff used Series A or Angel, other, and then let's say Series C, and let's say other and Series A. The question is, or the query is, what companies have received investments in the same investor? Okay, same investor in multiple funding rounds. Multiple meaning at least two different funding round. At least two. Use self-join and try to use multiple ends for the filter. So in the result, you need to return A because company A have same investor, and that particular investor in each of its investment use different funding round type. B should also be returned because you have the same investors, different funding round types. C and B would not be included in the result because they only have one investor. Okay, so same investor with different funding round type. This one is not also included. Like we have this and then another series A. This is not also included because even if the investor is the same, the funding round type is also the same. They should be different. They should have multiple funding round types. So in this, the hint is you need to use self-join. In this data set, you need to use self-join. So what does it look like? It looks like this. You will use self-join. It will look like this. Let me separate them. Ideally, they look like that. This part and this part. If you use self-join, literally, you copy and pasted two columns side by side. That is if, let's say, we use companies as the connecting values, or we join them on companies. using software. Does that make sense? Is that clear at this point, everyone?
Yeah.
Okay, so that is clear. So referring to this, how can we say that? Okay, so let's say this one is copy one, copy one. This one is copy two. Let's give them proper names so that the idea would be much clearer. And when we apply it into the real question, it would be easier to understand. So I have copy one and oops, let me use different color this way. Okay. On these two copies, okay. On these two copies, how can you say that